Hey, what's up? This is Randy. Today we're going to talk about one of the most useful tools in dealing with logarithms. It's called the change of base rule. Here we go. So before we actually get into the change of base rule, let's talk about a few quick points. We'll start with this first one, the common logarithm. So you've heard me explain the common logarithm briefly in a previous video, but what are the different ways that you can actually write the common logarithm? Well, you hopefully already know you can say log base 10 of some number. We're just calling that a. You could also say just log of a because that 10 is implied, as we've talked about. But one other way that you could write the common logarithm is by saying lg of a. So whichever of these three forms that you come across, just know that they're talking about the common logarithm, log base 10 of something. Now, a term that you maybe have not heard of before is the natural logarithm. Before we even talk about the natural logarithm, let's talk about this e right here. It's called the mathematical constant. So e is equal to 2.7182818, and that number keeps going. It has applications in things like compound interest, but for our purposes, it is the base of what we call the natural logarithm. So you could describe the natural logarithm by saying log base e of some number, but you could also say ln of a, and that also is another way to describe the natural logarithm. All right, now let's talk about just one more quick thing before we get into the change of base. When we see a log, such as this one right here, this is log base b of a. What is the correct term to describe the b, and what is the correct term to describe the a? So you probably could have guessed that this part of the logarithm is what we call the base, but the other one, right up here, you probably would not have guessed. We call that the argument. So if you ever hear me refer to the base or the argument, now you'll know that I'm either referring to this part of the logarithm or this part of the logarithm. So here we now have the logarithm change of base rule. Before we go through this rule step by step, let's talk about the parameters. So the first parameter is that the value for a must be greater than 0, and that a is referring to that part of the logarithm right there. In other words, the argument must be greater than 0. The next parameter that we need to remember is that the values for b and x must be greater than 0 and must not equal 1. So that parameter applies to this right here and both of those x's as well as this b again. The reason for these parameters is that if we don't follow them, for example, if we had like a value for a right here that was negative, then it's going to give us an undefined value. And in the same way, if we have a negative for b or x, or the number exactly 1 for b or x, then it's going to give us an undefined value. But as long as we follow these parameters, then we know that the change of base rule applies. So let's talk about this rule now. So this rule states that if we have log base b of a, so log base something of something, we can separate that into a fraction with a log on top in the numerator and a log on the bottom in the denominator with the same base. Notice that I put x here. Really soon we'll talk about what value I recommend for x. And in the numerator, we have an argument of a, which is the number from the argument in the original log, and on the bottom our new argument is b, which came from the base of the original log. Okay, so what's interesting is that you can choose any number for x as long as it's the same on the top and bottom, and as long as it follows this second parameter. So what do I recommend? I recommend that you always just use 10 for x because that's really easy to put in your calculator, and it also eliminates confusion if you know that you're always using 10 for that x. So what's nice is that instead of complicating your life with these x's, you can also just make the conclusion that log base b of a is the same as saying log of a over log of b with that implied 10 as the base for each log. This rule is so helpful. You have no idea how much it makes your life easier as you progress in mathematics. All right, so now let's do a couple examples that allow us to use what we just learned. So we need to evaluate the following logarithms and round our answers to the nearest thousandth. What is the nearest thousandth? That is 3 numbers after the decimal. So let's say that we have, some number right here, and then we have one number, another number, and another number. We need to round to the nearest third decimal place. So according to what we just talked about, log base 2 of 13 can be rewritten as what? Log of 13 over log of 2. Now let's talk about how this will look exactly in our calculator so that we don't make any mistakes. Now I always try to err on the side of using parentheses around a certain part if I'm not sure if it needs parentheses. So I put open parentheses and then click that log button and then open parentheses again and then type 13 and then close both this parenthesis and this parenthesis with both of those. And then we say divided by, and then that same pattern with parentheses. So open parentheses, log button, and then another open parentheses, and then 2, and then close both of those parentheses. And then what do you get? You should get 3.7004397. And when we round it to the nearest thousandth, we need to look at there's 3 places over. So look at this 4 and decide if we need to round this 0 up or not. Because 4 is not 5 or more, this 0 will not round up and it stays the same. So our number rounded to the nearest thousandth will be just 3.700, which we now can see is the answer, and that means that it is an approximation of log base 2 of 13. All right, now don't get freaked out by the second one because the logic is basically the same. And what's interesting is that you don't even need to use the properties of logarithms. Like some of you are maybe thinking, oh, we need to put this 15 as the exponent here. You don't have to do that in order to simplify all of this. But I will tell you that if you put the 15 as an exponent right here, so that little 15 right there, and then you get rid of it there, and then you simplify correctly, you'll still get the same value. But I vote that we don't complicate our lives if we don't have to. So let's get rid of that 15 as an exponent and just leave it in front like that. So this 15 is being multiplied by everything after it. So what I think that we should do is get an approximate value for everything inside of those parentheses that I just put, and then we'll multiply that value by 15. So the change of base rule tells us that we can rewrite the logarithmic part of it as a fraction like this. And how is all that going to look in our calculator without the 15? All right, there it is. So when you put all of this in your calculator and press equals, what value do you get? So you get negative 0.0829677, and that number keeps going. So from there, I recommend that you leave that long number in your calculator and then just immediately press times 15. And you get approximately negative 1.244515, and that number keeps going. So now when we round to the nearest thousandths, we need to look at the thousandths place, this 4 right here, and then decide if we need to round it up or not. The number after is a 5, which means that this 4 right here will round up to a 5. So now we can say that 15 times log base 5 of 7/8 is approximately equivalent to negative 1.245. And there you go. That was the logarithm change of base rule. See you next time. Hey.